Welcome back, and we are still in 5.2. We're dealing with electron configurations, which tell you where around the nucleus the electrons are arranged so that they can get as close to the nucleus as they can and feel that attraction, because one is positive, one is negative, yet the electrons have to be spaced out as much as they can because they're all negatively charged and they repel one another. And that's what these electron configurations do. Last time, we took a look at the electron configurations starting with sodium, and we introduced you to the idea of these inner electrons, which are called core electrons or kernel electrons. They are the electrons that are not in the outermost energy level, and they are not involved in bonding or in chemical reactions. It's only the valence or outer electrons that are. All right? And so we went through and took a look at several atoms, including argon, potassium, and scandium. And I told you that the periodic table will tell you exactly what the electron configurations are. And it's because the periodic table, number one, is set up by increasing atomic number, the number of protons, but it is also set up by electron configuration. The reason why we study electron configurations is because the electron configurations give you the properties of the elements. And every column of the periodic table has the same outer configuration. The first column always ends, the elements always end, in an S1 configuration. This top element, this is hydrogen. That's a 1s1. Okay? The second one here, which would be lithium, would be a 2s1. All right? It would be a 1s2, 2s1. When you get to sodium, go back and take a look. Sodium ends in a 3s1. Potassium ends in a 4s1, 5s1, 6s1, 7s1. All right? When you get to those elements that are in the second column, they always end in s2s. When you, except for helium, which is over here, that's kind of an oddball sitting off there on its own, but that's just something that you'll have to remember. Okay, everything that that ends in this block right over here, this is called the p block. They're always going to be filling the p orbitals. Let me change that to blue since it's already in blue. Let's go to that blue color there. Trace that again. Okay, everything that's right here, that always ends in p's. All right, you always have your p1s. The first electron has to be a p1 when it's going into that block. You also have the D block and the F block. So the periodic table tells you exactly what you need to know. So as you go through the periodic table, and you should have one out in front of you again, starting with hydrogen, let's walk our way through the periodic table because it's going to tell you what the electron configuration of the elements are. Let's just go ahead. I'm going to actually take this very last element. It doesn't actually show up on this particular periodic table. This would be element 118. It has 118 electrons. Now, what would the electron configuration for an element that was at the very end of the periodic table be? Well, there's a couple of rules that you have to follow. First of all, the S and P block, I'm going to change colors here so we're not confusing ourselves. Let's go with black. Okay, the S and P blocks fill the current energy level. Simply meaning, when you're in the first row, you're filling the 1s. When you're in the second row, you're filling the 2s and the 2p. When you're in the third row, you're filling the 3s and the 3p. When you're in the fourth row, you're filling the 4s and the 4p, and so on and so forth. When you get down to the seventh row, you're going to be filling the 7s and the 7p. When you're filling the D block is always one energy level behind. So when you are in the fourth row, you're actually filling the 3 Ds. When you're in the fifth row, you're actually filling the 4 Ds. When you're in the sixth row, you're actually filling the 5 Ds. And when you're in the last row, you're actually filling the 6 Ds. They're always one behind because of the overlapping that occurs. And finally, when you're filling the F block, which is down below, you're always 2 energy levels behind. Now, if you notice on your periodic table, barium, which is element 56, which is right here, that's where element 56 is. Element 57 is actually, well, 57 actually will be fitting either here or here. It gets a little bit confusing through there, but we don't have to worry about there are some exceptions that occur and some weird things that happen down there. But the basic idea is that the F block actually fits right in here. All right. The periodic table actually has a slightly different shape. We simply take the F block and put it down below. So what the pattern is, you go to element 56, then you go to element 57 down below, work your way across. When you get to the last one, this would be element 70, and then you have to jump up to element 71, which would be here. Then you're going to work your way across the periodic table, but when you get to element number 88, which is radium, you're going to have to jump down now to element 89, which is actinium, which is down here, and then work your way across the F block. Okay? So, all that being said, I think it's easier if we just go ahead and give this a try. If you wanted to take a look at element 118, the 118 electrons, where are the electrons placed, and what is the electron configuration? Okay? Here's how this thing works, and once you get the pattern, you're going to want to say it with me in your head or out loud. That also helps. Alright, so the electron configuration would be, starting at the top, would be a 1s2, 2s2, go across, 2p6, 3s2, 3p6, 4s2. Okay, now you're in the D block, that's one energy level behind. This is 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, jump down, 4f14, jump back up, 5d10, 6p6, 7s2, jump down, 5f14, you're one energy level behind, back up, 6d10, and then 7p6. So once again, looking across the periodic table, if you were to write the electron configuration out for element 118, follow along and we'll write this out. It would be a 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10 because it's one energy level behind, 4p6, 5s2, 4d10, 5p6, 6s2, jump down now, 4f14, back up, 5d10, 6p6, 7s2, jump down, 5f14, back up, 6d10, 7p6. That would be the complete electron configuration, which shows where all 118 electrons are located. Alright? That takes a lot of practice. If you're not really following what we're trying to do there, that's normal. We're going to try to go over this in class. Try to watch the podcast again, because again, the more times you see this, the more you understand it. The reason why we want to know electron configurations is because elements that have the similar electron configurations will actually behave in a similar way. Okay, scrolling down. So if you've got this figured out, go ahead and try these electron configurations. Whoop. What are the electron configurations for the elements that are on this next page? And we'll be going over that in the next podcast.